Hello and welcome to another session in mathematics. In this session we'll be looking at geometric progression, otherwise known as GP. But before that, let us take a review of our previous lesson. Welcome back. Today we'll be looking at a part of sequence and series that we've been dealing with for some time now, and the aspects we'll be looking at is the geometric progression, GP, and the nth term of a geometric progression. Okay, so let us start. A geometric progression is a sequence in which a constant number is being multiplied to get the next term. Now when we're talking about arithmetic progression, I told us that it's a sequence in which a constant number is being added. When we talk about arithmetic progression, we talk of addition. But now in geometric progression, we talk of what? Multiplication. Instead, a constant is being multiplied to get the next term. A constant is being multiplied to get the next term. And the constant number is what we call common ratio. Common ratio. Okay? Under the arithmetic progression, we call it common what? Difference. But in geometric progression, we call it what? Common ratio. And we use small letter r to denote it. Small letter r. Okay, and our common ratio, which is r, is obtained by dividing the second term by the first term, and then by dividing the third term by the second term, and so on and so forth. Okay, so assuming we are given a problem, let's say 2, 4, 8, 16, 32, and so on, and we are asked to find the common ratio. The common ratio is equal to 4 divided by 2, and that will give us what? 2. Or we can say 8 divided by 4, and that will give us 2. Or we can also say 16 divided by 8, which is still 2. Or we can say 32 divided by 16, which is still 2. So that's how we obtain what? The common ratio. The common ratio. Okay, let us take an example to check if you've been following in everything we've been doing from the first day we started the series and sequence. I said identify whether the sequence is an AP or a GP. Is very, very important for you to be able to identify a GP and an AP. It's very, very important for you to be able to differentiate these two things, geometric progression and arithmetic progression. So when a question is given, the first thing you need to do is to be able to do what? To differentiate between the both of them, understand the one that is given to you. You need to determine whether it is a GP or an AP. Then that is now what will help you to be able to solve it. How do you obtain that? You obtain that by checking what? The common difference and the common ratio. For the first example, we are asked to find whether it's a sequence in AP or a GP. So what do we do? For AP, we have our common difference to be equal to D, and we said it is what? T2 minus T1. Is that correct? So our T2 here is what? Is 8 minus 5, which is our T1. That will give us what? 3. Let us check another one. We have T3 minus T2, and T3 is what? 11 minus 8. What do we have? We have 3. So this is what? An arithmetic progression, since the common difference is equal. Okay. Number 2, we have 3, 9, and 27. Checking whether it is an AP, we take what? The common difference, and the common difference, like I said, is T2 minus T1, and our T2 is 9 minus our T1, and our T1 is what? Is 3. 9 minus 3 will give us what? Will give us 6. Okay, considering T3 minus T2, our T3 is what? Is 27, and our T2 is what? Is 9. 27 minus 9 is equal to 18. So this is not what? An AP. So let's try using the GP. I told us that GP is equal to T2 divided by T1 and that will give us 9 divided by 3, which will give us 3. Trying T3 divided by T2, we have 27 divided by 9, which will still give us what? 3. So we've confirmed that this is a GP. Okay, let's now quickly look at the nth term of a geometric progression. The nth term of a geometric progression. Okay, the first term in a geometric progression is given as small letter a, because it's the first term. The second term is determined by multiplying the common difference with the first term. So we have our second term to be equal to AR. Okay, second term. So our third term, which is T3, would then be equal to A times R, which is equal to AR raised to power 2. Our fourth term, which is T4, would then be equal to A times R, which is equal to AR raised to power what? 3. So generally, to find Tn, our answer would then be equal to AR raised to power what? N minus 1. That is for geometric progression. So let's quickly take an example on this. Example number 1. Find the sixth term of the sequence 3 minus 6 and 12. Find the sixth term of the sequence 3 minus 6, 12, and so on. Okay, let's start. Solution. I told us that Tn is equal to AR raised to power n minus 1. So our system will be T6 to be equal to AR raised to power 6 minus 1. But we need to find the value of A and the value of R, where A is our first term. Our first term in the sequence is 3. Our R is equal to T2 divided by T1, which will give us minus 6 divided by 3. And what do we have? We have minus 2. Okay, so our R is minus 2. Applying the values here, we have T6 to be equal to our A is 3 times R, and our R is what? Minus 2 raised to power 6 minus 1. Our T6 will be equal to 3 times minus 2. 6 minus 1 will give us 5. And 2 raised to power 5 is 32. So we have T6 to be equal to 3 times minus 32. And 3 times minus 32 will give us minus 96. And that's our answer. Okay. We have number 2. What is the seventh term of minus 8, 4, minus 2, 1, and so on? The seventh term. Solution. Okay, let us find we have our Tn to be equal to AR raised to power n minus 1, where our A is the first term, which is minus 8. Our R is equal to T2 divided by T1, which is equal to 4 divided by minus 8. And 4 into this F is 1. 4 here is what? Is 2. And this minus 1 over 2. So we have our R to be equal to minus 1 over 2. Okay, so T7 will be equal to A, which is minus 8, times minus 1 over 2 raised to power 7 minus 1. This is minus 8 times minus 1 over 2 raised to power 6 minus 1 over 2 raised to power 6. Okay, so we have minus 8 times minus 1 over 2 raised to power 6 will give us minus 1 over 2 raised to power 6, and that will give us minus 8 times 1 over 64, and this is equal to minus 8 over 64, which will then give us here is 1. 64 divided by 8 will give us 8, and that's the answer. Okay, To refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to introduce geometric progression, and we've done the nth term of a geometric progression. We'll stop here today. So do well to use the lesson note on the platform for better information and understanding of what we've just done, and feel free to drop your questions or comment on the comment section. Till we meet again in our next class, stay safe and bye.